I hope Gradle doesn't need much introduction, but just for sure, how many of you use it? Okay, at least few. So for the others, like Gradle is a tool which allows to orchestrate builds, namely for the Java and Kotlin and related languages. It has like much broader scope. Basically, you can use it, for example, to build JavaScript or Python, but it's not much used outside of the JVM world. But I would say in JVM world is one of the standards now. So I will be talking about my recent experience about like refactoring and improving the Gradle builds in good data, namely, but also like in other projects. Shortly about me. So you can call me Jimmy. Actually, I have two jobs. The first one is more serious for good data. The company which does the data analytics, selling worldwide as a SaaS company. And the other one is more like for fun. It's a small Czech-based company doing smart home installations. But actually, both jobs are fun. Apart from that, I'm climber, dancer, musician, father, and so on. So we can chat about also like more or less work-related topics if you want. However, now let's dive into our lecture. So this is about my journey to the effective and maintainable builds. Like in good data, we have like, let's say, two products. One is very legacy, the other one is very new. It means that there are like dozens, maybe hundreds of repositories with a lot of projects inside, a lot of modules, multimodules, whatever, and the build was like a huge mess. Actually, my experience is not about like refactoring everything, but like the significant part of the new product. First, I will try to explain like the challenges I was facing, or I believe probably similar projects are facing as well. Then the main part will be about lessons I have learned. Shortly about what's next, and maybe in the end, if there will be time, I will tell you some like tips which are not so related to the main thing. So let's go with the challenges. Probably everybody knows that in the beginning of projects there is usually single module, single project, single build. Everything is pretty simple. There is single repository, but then you find out that okay, you need another application or some tooling or whatever, another service. So you get more modules, but still you have single Git repository. You are happy. Most of your modules are alike. Are basically they have same structure, similar behavior, or they use similar libraries. So you can still like live with basically simple build for everything. But then you start with more projects. So more projects means, okay, you can still have single Git repository, but the projects are not so alike. But usually you don't want to invest into inventing something new, into studying, whatever. You just add your modules in your multimodule, what you have had. And basically, the result is that it's getting slightly more complex. There are some ugly ifs in your build logic and so on, but it still somehow works, but it's getting slow. And then your company grows and you have several Git repositories, several thousand of them, with several projects in each, with several multimodules. And yeah, this is totally not alike. And your builds are becoming unmaintainable. Basically, you can't add a simple module without like several days of deep diving into the build, like what the hell is going on where. So yeah, we know that this is not new. You know it from your projects, but this is related to the build. So in the end, you have a lot of copy paste. It's totally complex, meaning like parent projects are often containing like some build logic which are only for something. Sometimes it's only for single submodule hidden somewhere deep inside, but it's in parent project, and that pure module deep inside basically don't know like there is such logic in its build. Yeah, and it's of course too slow. Yeah. Examples. Yeah. It is. Okay, so this is like simple example. For example, yeah, how you will probably use or you use some internal repository for your artifacts, for your libraries. So what you typically end up that you copy this part of code to every build in each Git repository. We probably all know that. Like, it's a few lines, but copy it among dozens repositories, and then somebody decides that, okay, let's change this URL. So that's a trick. So not nice, right? The other examples. Okay, we have these sub-projects in the parent project, and suddenly we found out that we want to apply a lot of plugins, but we don't want them for the open API or some dependencies. So we invent something like this ugly if. But what if there is somewhere another project which doesn't need all of that? Or if there is some project which needs Java library but actually doesn't need Spring Framework? So then you start like mangling with those ifs, and it's getting overcomplicated. Like you can also notion here that, for example, this is applying Spring Framework boot, but actually it disables boot jar. Like, what the hell? Probably need it for somebody, someone. Maybe somewhere else it's again enabled. Who knows? Okay. So there are, in my eyes, 4 challenges in the end. Like, first, we need to get oriented. What is happening where? How? So that's the observability part. Then there is the challenge, like ensuring the basics, for example, that internal repository being shared across the repositories. Then, like, okay, we probably have a lot of deliverables, different projects which are delivered independently. They need to be built independently. But at the same time, most of them are using Java plugin with probably all the same settings, since like we want to align on the compiler arguments and so on, right? So why not? But how to achieve that if we split the builds and it won't be one huge pile of spaghetti? So that's another challenge. And we would like to continuously improve build effectivity. Because of what? Because time is money. So if every time you build your project, you can grab a coffee or two, or maybe like grab a beer around the corner. Like, yeah, that's nice for the beer, but not nice for your productivity. So let's talk about how I faced these challenges. So observability, pretty simple thing. Probably you know that. If you don't know that, start to use that. Like everybody knows probably these minus info, minus debug. Yeah, they are like pretty exhaustive, but can be useful. But be careful, since, for example, if you put minus info in your pipelines, you can simply exhaust the GitHub memory for the log, like pretty simply. Or also like these commands, like making the big build significantly slower. Try it. Definitely, sometimes it's like 20%, 30% more. Then there is this minus scan command. Like this is some kind of mystery. It was for me. So what it does actually, it only collects the statistics and all the metadata about the build, which happened, and in the end, it uploads it to the server. To what server? Basically, it turns out that Gradle runs such a server. They run it for free, so you can upload the scans there. You can examine your build. You can find a lot of useful information about your build, like what environment, how many CPU, how many RAM, what tasks were run, how was the concurrency. Lot of information. So I definitely recommend to use this. Like, also they do business on top of that. So if you want to upload it more and more and more, and you can you would like to examine it even better, so they have some intelligence on top of that, you can pay them. But the basic is for free, like even for commercial use. So I really recommend. Okay, so once you get oriented, you will find out such stuff like, okay, we have so many things which are basically copied all over and over. So how to do that? So basically, it turns out that Gradle have something which they call init scripts. It's some piece of Gradle code which is run before each build. Gradle discovers those init scripts in several locations, in the Gradle home, in the Gradle distribution. You can put those scripts even on command line. And you can combine many of such scripts. They are evaluated in alphabetical order. And it's basically the Gradle recommended way to set up environment-specific things. So how to leverage this for our use case? Basically, the way I did it, I actually rebundled the Gradle distribution, and through the wrapper I distributed through our repositories with our nice init script. Like it has, I don't know, 50 lines of code, but it's pretty useful. Here you can see the examples, like how to behave in that init script. For example, on the left side, you can apply some plugin management for all the settings. You can do something for all projects. You can react on plugins. For example, on the right side, I react on the presence of publishing plugin and configure some publishing extension, which basically allows my libraries to be published to internal repository. Let's go further. The other way are Gradle properties. Gradle has a lot of properties. You can find it in documentation. I don't be reading it out here. But what are these properties good for? They basically influence the general behavior of the Gradle and its JVM. And again, you can mix and match the same way as with any init scripts. So I did the same way. I basically bundle some Gradle properties to my custom Gradle distribution. You might think that rebundling the distribution is a hard task. No, it's not. Basically, the code base down here is everything what's needed. So basically, you download it somewhere. There is no download Gradle task visible here, but it has 3 more lines. So for the like making it big enough, I omitted. So, and also like, is this like correct? Making custom Gradle distribution? It appears it is. Basically, Gradle recommends it in its documentation. So you can like basically rebundle the download the official distro, add what you want, the init scripts, the Gradle properties. You can even like add some custom plugins which are like built in your Gradle distribution, and you can publish it somewhere in your network, like on some URL, and instead of the official wrapper URL, basically use the URL in your network. It just works. To the next challenge, how actually to make the builds more independent, but don't give up on sharing some part of the build logic. Okay, so first, on the left side, we can see like basically traditional multimodule. That's how most projects looked like and probably look like in the wild. So we have the root project, and everything is included in there. So in the root project settings, you just include everything what's related, even if it's not totally related. But it's just there. It's simple, and it's the way we evolve the projects. So basically, it's nothing so bad unless it's get too wild. So then it's time for composite. So the composite is on the right side, and it means that basically you decide your deliverable units or maybe working units. These are the units you create new independent build for. So for example, here we decided that we will deliver service A and service B like independently, meaning like I can work with them independently in the developing time, also like in the CI time, in the delivery time. And I don't need basically to even touch the build file of the service B or a build logic of the service B when I want to deliver service A. But they share some common lib. Okay, so there are two options. Either the common lib is just published as a jar somewhere, or if you use like monorepositories, you can just use this include build. That's it. So we'll include the build of the common lib into both, and it works pretty nicely. And also, if you want to develop just the common lib, you just work with the common lib, since it has its own build. So it's basically versatile, and again, nothing very new here. Like if you imagine like inheritance versus composition, that's about it. Like if you map it to what you know from your Kotlin code bases, for example. Okay, so just to wrap up, on the traditional multimodule, it seems simple in the beginning, but it's not simple. It's rather a huge pain in the end. Composite, the main advantage is that every deliverable can be developed independently. It allows focused work, easy to do isolated changes. The builds are smaller, therefore everything is faster. But now how to share the build logic? Basically, again, we use composition. What it means in the terms of build logic. We basically do the plugin. That's the way actually how natively Gradle does it. You can Gradle has a lot of plugins inside, and also there are like other plugins in the wild, open sourced. So why not to do our own plugins, basically with our own custom small pieces of code? One might think, okay, isn't it too hard to create a plugin, implement some APIs and whatever? It turns out it's not. Since the simplest way how to do the plugin is just take the parts of your builds, like put it into the separate module and name it by the name of the plugin. For example, here this CZ Smart Home Gradle Core. So the plugin is called CZ Smart Home Gradle Core. And on the right side, you can see the part of the code base. Here, basically, I apply some. Here is it. How is it used? I will get into the code later. Yeah, the other option. So they call this thing. They call it precompiled script. Like, it's really easy to do. Like you just write your Gradle code as you are used to. The other way is the more traditional. You can just really implement it using Gradle DSL APIs. It has some advantages, like namely, it's more versatile since you have more accesses to the deep level APIs, and in the end, it's faster since it's compiled. Like before, it becomes part of the build. But the precompiled script, it's still somehow compiled or translate in the configuration phase of the build. So, okay, probably that. So, sorry. So maybe the code will be there later. or maybe I just skipped, not sure. But let's talk about other aspect of the shareability. And these are the dependencies. We typically use, let's say, bundles of dependencies in our project. Probably not every project doesn't have like its own very specific set of dependencies and versions, so we would like to somehow share it. Gradle has like different possibilities for that. Try to explore them all, but what I have ended up is that I basically removed this Spring Dependency Management plugin. It's kind of surprising since we all like Spring, and so everything that comes from Spring is probably gold. I don't think this is the case. Why? Since basically this Spring Dependency Management plugin was invented in the early stages of Gradle and was developed basically for easy migration from Maven tool. So it follows basically what the plugin does, that it somehow tweaks Gradle to behave like a Maven. So do we want it? Like, then everything is somehow like twisted. So then you read the documentation about how Gradle resolves dependencies, and basically that's not the thing how it actually behaves, since you use this Spring Dependency Management plugin. But there is one more important reason. What this plugin basically does, that it enforces the exact versions of the libraries. And basically, it makes you explicitly declare dependencies which are even used transitively, which in the end can lead to binary incompatibilities. Since if you force all the versions and then you change one version of some library, and you are not aware that basically this library brings another library as a dependency, which you also force, but on wrong version, which are binary incompatible, the result is that you can get binary incompatible compilation in the end. So I really discourage of using this plugin, and rather I went for a more Gradle native way. And basically they have two different things. The one is called version catalog, which is basically some file. It can be in the Gradle build file, or it can be in some external file. But basically this is just the catalog. So the names of the modules with some version, which basically says, okay, this is the module and this is the default version. If the dependency resolution doesn't do anything else. What's also nice, that this version catalog, if you use Gradle Kotlin DSL, not in Groovy, but in Kotlin, you basically can use these dependencies, and you get the compile, you get the intentions from IntelliJ. Basically, it's a like compile time safe. So you got these module names as the variables or / properties in your Gradle code. So that's a nice thing. And there is the second approach is so-called Java platform or platform modules. This is something what we were in early days, in Maven days, we were talking about bill of materials. So it's something similar. So basically, this is something what serves as a hint for Gradle, like what library should be used in which version, even if used transitively. What's the difference between this platform and the Spring Dependency Management plugin? Since the difference is that basically with Spring Dependency Management plugin, if you declare the dependency version, it actually brings that dependency actively to your class path. But the platform doesn't bring the dependency if there is no other module which brings the dependency. So it only serves as a hint for Gradle what version to bring if that module is going to be brought. So that's the main differentiator here. Okay, so let's talk shortly about build effectivity. Naturally, this composite approach allows faster builds if you use it wisely. Like, of course, if you turn all your projects into the composite separate builds, and then first thing you do, that you just include build everything, and then just build, no, it's not faster. But that's not what we wanted, basically. We wanted to be more versatile, more independent, and we basically wanted to work on our projects like separately, and then it's faster. Then how to move it further? There are several approaches. Build cache. Build cache is something what's the Gradle natural thing, but surprisingly it's disabled by default. Why it's disabled? Since it can bring some confusion. Sometimes things are cached and you don't want to cache it, and then you need to learn that you need to put some no cache argument or whatever. You need to basically actively work with that. But I definitely encourage you to enable it and configure it. It even brings like improvements in CI, not only locally. What was also quite new, like this year, that there are like two types of caches, the local and the remote. So the local is stored usually in the machine when the Gradle runs. But the remote is basically some server. Again, Gradle is selling it, so you can buy it even and develop it against it. It will cost some money and probably it will be much faster. I haven't tried, so don't know. But also you can just download this caching service and install it in your environment. For example, in our case, we run it in our Kubernetes. It's nothing like rocket science. And especially if it's in your environment, it's even better since like it sits like in the same network. So you don't need to transfer the data throughout the ocean, over the ocean to basically hit the remote cache. Yeah, and these caches can be combined. So usually how Gradle behaves, it first tries to look up in the local cache and then the remote. The other thing which can make your build significantly faster is the configuration cache. It's there for some time, but it's only stable from Gradle 8. There is a trick. Like there are a lot of plugins and tasks which doesn't support it yet. You can find the exhaustive list in the Gradle documentation. Even there are some open source projects list, like trying to keep track on which plugins, even from the public and wild, need to be improved. Like if you write your plugin or task, it's nothing like very complicated to be like configuration cache aware, but it can be complicated to rewrite some very old plugin to be compliant. But most of the internal Gradle plugins which comes with the distribution support that, and yeah, it can be blazingly fast. Like basically from dozens of seconds to 2 or 3 seconds. So it definitely makes sense to try, mostly for local builds. Since in CI, basically we don't run often like many repeated runs of the Gradle. We just use just one Gradle build all or something like that, or some Gradle tests, so it doesn't make much sense. Yeah, more about effectivity. Try to find out information about JVMs which are used. Like Gradle typically spawns several JVMs. There is the wrapper JVM, which usually changes after itself to the client JVM. Then there is the client JVM, which communicate with the daemons. And daemons actually can run JVM per worker. So if you set somewhere in the Gradle properties use for workers, it means it spawns for JVMs. And then, for example, you put some JVM arguments, okay, for example, max heap to 4 giga, and you put there for workers, so it consumes 16 giga of RAM. Not very nice, so be careful about that. But also by that, if you have machine strong enough, you can like improve the efficiency of your build, like in the terms of like rough speed. Okay, so we are mostly on the end. So just to sum up my journey, currently, like we have this custom Gradle distribution with init scripts and basic properties, which allow us to share the basic things among the company. Then we have some set of common Gradle plugins, which we publish to internal repo. We also have some tiny version catalog, like shared among repositories. And typically we have like set of very tiny convention plugins in some bigger repositories, which are basically sharing the logic in that repository. Version catalogs, I have been mentioning that. So that's my journey. There are some possible improvements. Don't have much time, so I mainly mentioned the last one, and what I really would like to do is to provide some monorepo plugin, meaning if you have like a lot of independent projects in your repository, and sometimes your use case really is to do something with all of them. Sometimes it's something like very simple, like, okay, for example, get me a list of the dependencies of all of those, like for example, for some security reasons, or I don't know. So it would be nice to have such a tool. Like actually, I already wrote some of that code, but I don't have it like, let's say, productized as a plugin. Okay, so we are in the end. So probably skip the tips. And now it's question time.
You sort of touched, like mentioned CI from a distance a few times. With optimizing the multi-module and even multi-project repo with Gradle for the CI builds, do you have any tips on actually how to optimize it so it only builds what needs to be built and runs tests only for what needs to be tested?
Yes, actually we have such things. So that's one of the part of the code for the, like, let's say, monorepo plugin. What it actually does, and it's not hard to write, that basically it includes everything what's in the repository. It iterates or basically search recursively through the includes of includes of includes, and then it compares it to basically Git changes, and then you have basically the set of modules which needs to be built and tested. So it's nothing like very, but surprisingly I didn't find any open source to do it. But actually I wasn't writing it, but my colleague wrote it on like 30 lines or something. So it's not.
So like this can actually be done on the Gradle level.
Yes, we did it on the Gradle. Yes, basically we use GitHub Actions. So basically the GitHub Actions just call the Gradle task, which produce the YAML file saying like what needs to be built like in the next step.
Thanks.
Okay, there. I wanted to ask you which DSL do you use now on your daily basis, Google one or Kotlin one?
Not sure if I hear good, but just to repeat, so it's about like what language or what flavor of Gradle?
Yeah, what DSL?
What DSL? Okay, so the question was like if we or me are using Ruby or Kotlin DSL. Basically, while working on this project, I rewrote everything from Groovy to Kotlin DSL. It wasn't very hard to do. There are still some parts which I left in Groovy, but they are gonna to be deprecated. But the good thing is that if you wanna migrate, that you can combine even in single build. Like you can't combine in one file, but you can have multi-module build and one project in Kotlin and the other one in Groovy. The question is, if I use the traditional multi-module style and I don't want to use all the plugins which are basically declared in the parent, if I can disable them, yes, I can just apply false. But what's the difference against the composite approach? For example, let's say, let's talk about that Spring Framework Boot plugin. It's like pretty huge beast. Like check the size and its dependencies, like in your build scan. So meaning that if you declare it, even with apply false, the Gradle downloads it, and it downloads all its dependencies. So it's a network time, which is expensive. Like imagine you are a developer somewhere on Seychelles, and you are downloading everything from, I don't know, US East. Okay, it will take some time. Also like speaking about CI, that's also like now the trend is basically to start like from the scratch, always like in the CI. So meaning it will always download everything, even if you apply it false.
Okay, thank you very much again, Jiří, and we will take a 10 minutes break. And once again, thank you very much.
You're welcome.